The faster a car is travelling, the further its stopping distance will be. Remember, the stopping distance is the distance travelled between a need to stop appearing and a car actually stopping. So let's suppose we have two cars, one travelling at 30 miles per hour and the other at 60 miles per hour. Both react to the same danger on the road. We'll assume both drivers have the same reaction time and both cars brake with the same force. The only difference between them is their initial speeds. If we measure the distances the two cars travel before they stop, then we find the faster car has the longer stopping distance. This is an important fact to remember, and in your exam, you might be asked to estimate how a stopping distance would change if a speed changes. But why does the distance change? Well, to answer that question, we should remember the two components that make up the stopping distance. Firstly, the thinking distance. A faster speed means more distance will be travelled during a reaction time. And by reaction time, we mean the time it takes for a driver to apply their brakes after a danger appears. As the cars are still travelling during this time, this results in a thinking distance for each one. Even if the driver's reaction times were the same, we'd still notice a difference in these distances. Remember that we can calculate a distance using distance equals speed times time, or S equals VT. So if the reaction time doesn't change, then a larger speed means a larger thinking distance. In this case, since a faster car has double the speed, it has double the thinking distance. Now let's look at the second component of stopping distance, which is the braking distance. A faster speed means it takes longer to decelerate and the car travels further while doing so. So even if both cars have the same braking force and deceleration, the faster car will have a longer braking distance. This is because it has more speed to lose, meaning it takes longer to decelerate and travels further in this time. Notice this time the distance for the faster car more than doubles. You don't need to be able to calculate this distance, but you do need to take this into consideration if you're estimating how a stopping distance changes. Now let's look at why it's important to consider the relation between speed and stopping distance. Stopping distances are considered when determining speed limits for roads. In the UK, most roads outside of motorways, i.e. roads in towns or cities, have a speed limit of around 30 miles per hour. Some of these roads will have a limit of 20 and others a limit of 40. It all depends on how short we need the stopping distances of cars to be. Let's discuss some factors that determine this. First, we need to consider the chance of sudden hazards. Are there going to be pedestrians or animals running in the road? Will a car suddenly turn into the road ahead of you? How often will drivers have to stop for this? Next, we should think about how much traffic there will be on the road. How much distance will there be between two cars? If the car in front suddenly stops, does the car behind have enough distance to stop in? The number of junctions a driver encounters also needs to be considered. How often will the car need to be stopping for these? How far away can the driver be before they notice them? Finally, what pedestrian crossings are on the road? How often do cars need to stop to let pedestrians cross at zebra crossings or traffic lights? All of these are considered when determining a speed limit. If cars travel too fast, then they'll have longer stopping distances and the greater chance of them not being able to stop in time for these. You don't need to remember all of these factors, but you should be familiar with them as you may be asked why a road would have a certain speed limit. If so, make sure to mention stopping distance in your answer.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!